Good day everyone, I'm Jolene de la Cruz and I'm gonna tackling about the multi-view of orthographic exercises. Orthographic projection or exercises is a common technique used to produce mechanical and architectural CAD drawings. Multi-view orthographic projection drawings allow the drafter to represent a 3D drawing in a 2D environment. Multi-view drawings can consist up to 6 principal views: front, back, top, bottom, left side, and right side. Most multi-view drawings have 3 principal views, but more views may be shown to complex objects with lots of details. Additional information. A multi-view orthographic projection is a drawing technique in which up to 6 images of an object are produced. With each drawing, the object is behind the plane of the projection and the object is positioned in such a way that only 2 in its dimensions are shown. The parallel lines of sight go through the projection plane and the features of the part are outlined. Perspectives in orthographic and multi-view projection include linear, axonometric, and oblique types. So that's all. Thank you for listening, and to conclude, all the orthographic exercises will be explained to my fellow reporters. Thank you.
Good day everyone. My name is David Justin Kinubas and I'm going to report the pictorial drawing. Pictorial drawing is a type of illustration that represents a 3D object in a single 2D drawing, showing multiple views at once. Common types include isometric, oblique, and perspective drawings, which are used in fields like engineering and art for clarity and communication. This method is often easier to understand than traditional multi-view drawings, with separate front, top, and side views. So, types of pictorial drawing. Number 1, isometric drawing. Shown 3 faces of an object with all 3 axes at a 30 angle to the horizontal plane. All 3 dimensions are shown in a single view. Oblique drawing. The simplest type, which shows the front face of the object in its true shape. Lines of depth are drawn at an angle to represent the third dimensions. Perspective drawing. Create a realistic view that mimics how the human eye sees. This is achieved by using 1, 2, or 3 vanishing points where parallel lines appear to converge as they recede into the distance. Purpose and application. Communication. Pictorial drawing provide a clear single image representation of an object, making it easier for designers, manufacturers, and clients to understand a project. Technical fields. They are essential in technical drawing, drafting, and engineering for presenting designs accurately. Education. They are used in exam and technical education to help students learn about 3D object and spatial relationship. So, other uses. The term can also apply to illustrated books or photo albums that are primarily made up of pictures. That's all. Thank you.
Hello everyone, this is Bea Crispy Damandaman, and now let's talk about isometric drawings. An isometric drawing is a type of 3D drawing that shows an object from a corner view where height, width, and length are shown. These three dimensions are shown in a single view and is a type of 3D drawing used to show an object without using perspective. So when we say 3D drawing, no? Three-dimensional. So, three ka dimensions ang makita nimo. And then, makita nimo from a corner view. So, mean kanang magpakilig gani ang view. Makita nimo ang front view, ang side view, and of course, ang top view. Tapos, makita sa nimo ang iyang height, width, and length sa object. And then, kaning tanan dimensions, tulo ka dimensions sa isometric drawing or object is makita mo siya in a single view. So, sa katutok pa lang nimo makita na nimo daan. Makita na nimo dayon ang top view, ang front view, ang side view sa object, no? And then, also, dili siya need mag-use of perspective. No, dili siya need mag-use of 1-point perspective, 2-point perspective, or 3-point perspective if mag-drawing ka og isometric object. These are some of the examples of isometric drawing.
Good day everyone, I am Candelaria May and today I'm going to discuss about principles of isometric projections. Isometric projections represents a 3D on a 2D surface by viewing it so that all three axes, which is y, x, and z, are equally foreshortened, creating a 120-degree angle between each pair of axes. Key principles include maintaining parallel lines using specific angles, 30 degrees for horizontal lines from the plane, and ensuring that all dimensions are equally reduced to keep proportions accurate. And here's are the key principles of isometric projections. First one, equal foreshortening, and the second one, 120-degree angles between axes, and third one, specific angles per line, and the fourth one, parallel lines stay parallel, and the fifth one, maintaining scale. So what is the equal foreshortening? All three dimensions, which is the length, width, and the height, are reduced equally, meaning no single dimension is integrated. And what is 120 degrees angles between axes? The three axes of projections meet at the center and form 120-degree angle with each other. And the third one, specific angles for line. Vertical lines remain vertical, while horizontal lines are drawn at a 130-degree to the horizontal plane. And the fourth one, parallel lines stay parallel, and lines that are parallel in the object remain parallel. And the drawings is simplifying the process of creating accurate presentations. And the fifth one, maintaining scale. What is maintaining scale? To ensure accuracy is a special isometric scale is used, which represent the true measurements of the object in reduced form. So that's all everyone. Thank you.
Hi everyone, I am Kyra Kiskaguates from BIT DT1B and I will be discussing about the isometric scale. Now what is an isometric scale? Isometric scale is a special scale used in isometric drawing to make true measurements look proportionally correct when drawn along the isometric axis. Because isometric drawings tilt the object at 30-degree angle, normal measurements will look distorted if plotted directly. So to fix this, we use an isometric scale to convert true length into isometric length. Now why do we need it? When an object is drawn at 30-degree angle, the lines appear shorter than their true length. So the drawing looks off if you use the real measurements. When using the isometric scale, it adjusts the measurement so it appears correct in isometric view. To make an isometric scale, the first thing that we're going to do is make a horizontal line, which is the x-axis, and our y-axis. Next is to create a line in 45-degree angle and another line at 30-degree angle. Now we have our isometric drawing at 45-degree angle and our isometric projection at 30-degree angle. Next step is we need to divide our scale. I divided mine into 10 mm, and what we do next is to project it down. And we have here some examples of dimensions when creating an isometric projection. We have here 90 millimeters, which is equivalent to 78 millimeters. Next is 30 mm, which is equivalent to 25 millimeters. Then we have 50 mm, that is equivalent to 40 mm. And that ends my discussion here. Thank you for listening.